This video will be about airflow. Why does air start flowing and in what or which direction? Learn to understand the concept of wind pressure-induced airflows, air tightness, stack effect, ventilation system and the neutral plane. Wind-induced airflows. We have on the windward side positive pressure from the wind, and this can cause air to penetrate into the building envelope, and as in this case go inside the insulation material and pick out and drag out heat, which will make the energy efficiency of building less good. This can be eliminated by wind barriers, which protect the building envelope from penetrating air originating from the wind. The positive pressure can also make the air flow into the building, and since we can't accumulate air inside, it will flow out in another place. And this, given extra ventilation rate that we don't really want, then this will cause less good energy efficiency of building, and it can also cause draft and thermal comfort problems. This latter problem can be handled by having a good air tightness. So to make continuous air barrier around the building envelope, so air can't flow either into the building or from the building outwards. The picture here on the right is showing blower door equipment. This is quite a common way of testing the building's air tightness. It's basically in a big fan. You mount it in the door hole, and you blow in air so you can build up an overpressure in the building or under pressure of 50 Pascal, and then you measure how much air that is flowing in or out the building, and then you get an idea of how tight the building is. Air leakages due to the stack effect. The stack effect causes overpressure in the upper part of the building and underpressure in the lower part. And this will cause leakages of indoor air flowing outwards in the upper part. And in this example we have acoustical tiles in the top of the ceiling. And since the air is flowing through these type of insulation material, porous material, they can, for instance, accumulate dirt and be discolored. Another problem is that it might bring out indoor moist air out to the construction in the ceiling. The ventilation system, if we just have a natural or balanced ventilation system, natural ventilation system means that we don't have any fans at all, no mechanical ventilation. That means that on an average we have the same pressure on the inside and outside. Then we might have the neutral layer somewhere in the middle of the building. If we have a balanced ventilation system, that means that we both will press in air with the fan and suck out air with the fan, and we can still have on average roughly the same pressure inside and outside. However, if we use just an exhaust ventilation system, means we just have a fan that suck out air from the building, the neutral layer, pressure plane, the neutral layer will move upwards, and then you can have a building with basically just outdoor air flowing into the building and not the other way around. So we move it up here by using an exhaust ventilation system. So we recommend exhaust-only ventilation system because that will cause air flowing inwards to the building instead of outwards. It also means that we have more dry outdoor air that is sucked in instead of indoor air that has higher moisture content that flows out and cause moisture convection problem. At least it's important to avoid overpressure ventilation system, where you actively press out the indoor air through the building envelope. If we have a naturally ventilated house, we can move the neutral plane upwards by having more openings in the upper part of the building. Summary. Good air tightness of the building envelope eliminates air flowing through the envelope, which gives both more energy efficient and moisture safe buildings. An exhaust mechanical ventilation system can lower and even eliminate overpressure in the building.